So this is the second worksheet, and I'm going to work through the first problem. I did this as an example in class. Okay, so it says, if I set a volleyball and it goes 5 meters into the air above the net, how long does my teammate have to spike the ball, starting from when I set it, before it falls below the level of the net? So that's the problem I'm trying to solve. This is a reflection problem. It is almost exactly the same as this one, so we're going to solve it in the same way as we would the one with the tennis ball going 2 meters up in the air and coming back down. But I'll just go through that right now. So I'll start off with a picture. Again, this is a reflection problem, which means that the volleyball is going up and it's coming back down. Because of symmetry, it's going to take the same amount of time to go up as it does to come back down. So what I'll do in this problem is I'm just going to solve for it falling down 5 meters, starting from rest at the top. So whenever something goes up, it goes up to its maximum height, and then it's at rest for an instant, and then it comes back down. I'm just going to solve for that second half of the problem, and then I'll double the time. That'll give me the total time between the set and when the spike has to happen. 5 meters would be a pretty high set, so this is sort of a longer time than it would be in a game. You'd try to set it less than 5 meters. Okay, so I'll start off with a picture. So we've just got a ball. It's falling down. I'm going to say 0 is the bottom. I'll say 5 is where it's starting. The acceleration, I know, is always 10 meters per second squared towards the ground. All right. Question, what do I need to know? I'm looking for time. What do I already know? I know that it starts off at 5 meters. So that's given in the problem. So I'm solving the problem of something starting at 5 meters, ending at 0. So x final is going to be 0. Our acceleration is going to be negative 10. It's negative 10 because I'm going to call this direction positive. So up is positive, down is negative. And then it starts at a velocity of 0. So when it gets up to that highest point, it stops for an instant and then it starts to fall. The problem we're solving is going from that stopped instant back down to when it's 5 meters lower than when it started. Okay, so that's our setup. This is what we know. That's what we're looking for. We're going to look through these equations. Again, we don't have VF, so the last 3 equations won't work, so we'll use the first one. So that gives us XF is equal to XI plus VIT plus 1/2 AT squared. I'm looking for T. I'm going to sub in my numbers right now, and then we'll solve for T. So X final, we're going to say 0 is equal to 5 plus VI is 0 times T plus 1/2. Our acceleration is negative 10 times T squared. Okay, so again, just rewriting this equation, putting in numbers for my variables. Now I'll simplify it. So 0 times T is just 0, so I'll say 0 is equal to 5 plus 0 plus 1/2 times negative 10 is negative 5, and then T squared is going to stay at T squared. I'm trying to get T all by itself. I draw the T's with a little like loop on the end just to make it look different from the plus signs. That can help. Okay, so I've got 0 is equal to 5 plus negative 5 T squared. All right, I want to get T squared by itself. I've got this 5 here. I'll deal with that first. So I'll subtract 5 from both sides. I get negative 5 is equal to negative 5 T squared. All right, then I want to divide. So I'm going to get rid of this negative 5 by dividing it. So I've got a negative 5 times T squared. So the opposite of multiplying is dividing. So that's how I get rid of that. That goes away. I end up with negative 5 divided by negative 5 is just 1. That equals T squared. And then to get T by itself, I got to take the square root. So I'll take the square root of both sides. That cancels out the square, so I end up with T equals the square root of 1. The square root of 1 is just 1. So it would take 1 second for something to fall from 5 meters up in the air down to 0. Okay, so I'm going to call 0 that's where I'm stopping the timer. That's the top of the net is at 0. The ball starts 5 meters above the top of the net. Takes 1 second to fall down, which means the total time between when I set it and when I spike it is going to be double that, because it takes half of the time to get up to the top and then the other half of the time to go down to the bottom. We know that 1/2 of the time is 1 second, so the other half of the time is going to be 1 second. Our total time is going to be 2 seconds. And that's our answer.